Last class we started estimation. Today we continue with estimation, and I'm sure that you also got some time to brush through the concepts what already being told to you. And as usual that our today's lecture is also under confidence interval, and it is primarily for difference of two population means, which was started in the last class, and then today again we will continue with this. In addition, we will discuss confidence interval for ratio of two population variances. We will show you some of the examples. Let us go next. Last class what we have seen, that we have seen the confidence interval for mu1 minus mu2, where mu1 is the mean for population 1 and mu2 is the mean for population 2, and we have used this formula, that x1 bar minus x2 bar minus z alpha by 2, then your square root of sigma 1 square by n1 plus sigma 2 square by n2 less than equal to mu1 minus mu2 less than equal to x1 bar minus x2 bar plus z alpha by 2 square root of sigma 1 square by n1 plus sigma 2 square by n2. This is the case, and we have seen one example also. What I have said, that method A and method B, that these are the two teaching methods, and this is the formulation. Only thing that here Z 0.025 you write, this one, this is not 0.05, this will be Z 0.025. So, using this formula like this one, what are the prerequisites, what are the conditions? Conditions are many. First of all, sigma 1 and sigma 2 must be known, and you will be collecting N1 and N2 this type sample size, and it is from normal populations, and but there is difficulty arises here knowing that sigma 1 and sigma 2. Another thing it may happen also, that sigma 1 equal to sigma 2, maybe that may be the case. Sigma 1 equal to sigma 2 equal to sigma. Now, what does it mean? That the population variances are same, equal. If population variances are same, then we will not use this equation. We will go for, because of this special condition, we will go for another type of estimation, where we will use, first we find out that what is the estimate of sigma. The reason is, as sigma 1 equal to sigma 2 equal to sigma, and you have N1, N2, two set samples are available and from the two different population. So, we will, instead of using that one, that means you can go for sample 1 and calculate sigma estimate also. You can, that is basically sigma 1 estimate equal to sigma estimate, because they are same, sigma 2 estimate equal to sigma estimate. But in that case what will happen, you will may find out that sigma 1 sigma 2 will be definitely different, because they are coming from two population. So, and they are sample only. That is why what happened, we say that we will calculate S pooled. You will basically, the two sample will be pooled together, and then you will be calculating the estimate of that sigma cap, which is basically S pooled. So, now what is this S pooled? S pooled is, your S pooled will be like this, S square pooled you write. This will be, suppose the sample 1 of size n1 minus 1 S1 square plus population 2 case n2 minus 1 S2 square divided by n1 plus n2 minus 2. Getting me? What you are doing here? What is this? N1 minus 1 S1 square, that is the total variability in the sample from for population 1. Second one is the total variability in the sample from the population 2 point of view, and this N1 minus N2 minus 2, this is the degrees of freedom available. The reason is you have calculated x1 bar, 1 degree is lost, x2 bar is calculated and that degree is lost. So, this is the resultant. This is what we are saying, that S pooled or variance, combined variance. Now, and this one we are saying that this is the estimate of sigma square. If this is the case, and if we consider that things are coming from normal population and sample size is large, in that case what will be your interval? X1 bar minus X2 bar minus Z alpha by 2. Then the variance, what you have written there in earlier case, what we have written? We have written like this, that sigma 1 square by n1 plus sigma 2 square by n2, then square root. Fine. Now, what is happening here? Here sigma 1 equal to sigma 2. So, I can write this one like this, sigma 1 sigma square by n1 plus sigma square by n2. This is nothing but sigma will come out and 1 by n1 plus 1 by n2. Now, you say that S pooled is the estimate of sigma. So, that means I can write SP. So, if I write SP equal to S pooled, then SP square root of 1 by n1 plus 1 by n2. Okay. So, you will be writing SP, that this portion is now I am writing again sigma square root of 1 by n1 plus 1 by n2 equal to SP 1 by n1 plus 1 by n2. Why SP? Now, SP is the estimate of sigma. Then your result, now your earlier derivation was like this, x1 bar minus x2 bar minus z alpha by 2 sigma 1 square by n1 plus sigma 2 n square less than equal to this, less than this. Now, this quantity will be replaced now. It will be replaced by SP into this. So, I will write here now SP 1 by n1 plus 1 by n2 square root, this less than equal to mu 1 minus mu 2 less than equal to x1 bar minus x2 bar, correct? Then minus, you write not minus, plus, I think you can write the rest of the portion, that means plus this one, this will come here, plus this. Okay. And most of the cases you will be, because sigma 1, knowing sigma 1 and sigma 2 is not possible, population variance, and then what will happen, you will be using this S1 and S2. But if S1 and S2 and the formulation like this, S1 square by N1 plus S2 square by N2, that variability formula if you use, then if your sample size is large only, that is better. But if sample size is small, there is doubt in this formulation. So, our one of the assumption will be that sigma 1 square equal to sigma 2 square equal to sigma square, that means population variance standard deviations are equal. That assumptions we will do, and because of this assumption you will be using S pooled. So, this is the equation. You find out that most of the time this equation is used, Z alpha by 2 S p square root of 1 by n 1 plus 1 by n 2. And it is also customary that we will go for equal sample size. So, n 1 plus equal to n 1 equal to n 2 equal to n also. If you use n 1 equal to n 2 equal to n, then what will happen ultimately? This is n minus 1, this one is also n minus 1, then it is 2 n minus 2 means n minus. What will happen if n 1 equal to n 2 equal to n? What will happen then? Your S p square equal to, or S pool this square equal to n minus 1 S 1 square plus n minus 1 S 2 square by n plus n minus 2. So, this will become n minus 1 S 1 square plus S 2 square by 2 into n minus 1. So, resultant will become S 1 square plus S 2 square by 2, and in the equation you use. Okay. And when another condition is, suppose if I go to the, I think next one is not there. Okay. What will happen if n 1 less than an n 2 or n 1 and n 2 are both small? Okay. So, you will be using T distribution. What will be the degree of freedom for this T distribution when you use S pooled? Minus 2. Getting? That is the big issue. So, ultimately you are calculating this and you have computed, you have this much degree of freedom available. Okay. So, you have to go for n 1 plus n 2 minus 2 degrees of freedom. Okay. Then if I ask you that when you will use this formulation or the other formulation, first one, suppose this formulation Z, this formulation from the normal population it is coming, sigma 1 sigma 2 is known irrespective of this sample size, sigma 1 sigma 2 is not known, sample size is large, you are using this distribution. Okay. If sample size is small, sigma 1 sigma 2 is not known, then you have to first find out that the assumption is sigma 1 equal to sigma 2, that has to be found out. That assumption to be checked. If that assumption is true, then you have to calculate S p square, and then you formulate like this formulation and go for T distribution. Getting me? Now, if then how do you know that sigma 1 square, sigma 1 equal to sigma 2 or sigma 2 1 square equal to sigma 2 square? The equality of variance. How do you know that equality? That is to be tested, because if you want to use this formulation, you require to test also that the two population variances are equal. If two populations variances are not equal, then you cannot go for this. Fine. Suppose population variances are not equal, sample size are different, you cannot, and also population is not equal, sample size are small also, and then you cannot use Z distribution. and another issue will taken place that because of this different sample size. So, ultimately there are some other type of derivation is there that we are not considering here. Okay. So, essentially we are considering few things: sampling from normal population, either that variance component are known, and either sample in when variances are not known, that is large sample, and when variances are not known, also small sample, we are assuming that the variances are equal, and then we are using S pooled and we are going for T distribution under this case. Okay. If they are equal and some large sample size is large, then you can go for Z distribution, no problem. So, Z and T distribution for the equality of means of the two population, all those things, this is very mostly used. Okay. But where we ended now? We ended that if we want to use this, we require to know that the population variances are equal. So, can we not find out a test by which we can do that? This is this case. Can we not find out the other one? Okay. Before going to the other one, I think you can simply find out that how you can calculate the constructs interval, all those things we have discussed. Now, confidence interval for the ratio of two population variances. So, how do you test that two population variances are equal? Do you know any statistic, any test? Okay. So, 11 test is there in ANOVA, analysis of ANOVA, that is means analysis of variance, that is what is ANOVA. In ANOVA, what will happen? You will find out that one of the important test is that 11 test. We want to do that the population, the label variances are equal, then only go for mean test. Okay. So, 11 test is one that is there, we will see later on if time permits. Now, confidence interval for the ratio of two population variances, how do you go about it? What is this usual that our total our structure, what is the usual steps we follow? We will follow the steps like this, and okay, I have two populations, both populations, either here you are interested to test the ratio, that sigma 1 square by that you want to get something like this sigma 2 square, you want to get something like this. Something like this, what will be the L and U, and you are interested to know, this is the case. Now, if you want to get this interval, you must know that what is the statistic you will generate, and that based on that statistics you will go for the sampling distribution. So, that few things are important. You must know the appropriate statistic, then distribution of the sampling distribution of the statistic, and then what you will basically choose alpha value, appropriate alpha, that what you want, then you construct the interval. These are the steps, and everywhere you are doing like this only. If it is mean, your statistics is mean minus expected value of mean by variance, it will be Z or T. Then if it is variance, you are using n minus 1 S square by sigma square, that is the statistics, chi-square distribution. Now, if it is mean difference, again you are finding out the x1 bar minus x2 bar minus expected value by its standard deviation, that also follows Z or T distribution depending on the conditions. Now, we are talking about ratio of 2, and I think you all know, because we have discussed this, that n minus 1 a square by sigma square follows chi-square distribution with n minus 1 degrees of freedom. Yes or no? Now, let us see that it is our population 1, that sigma 1 is the variance, sigma 1 square is the variance. You have collected sample n 1 and you have computed also S 1 square. Then your statistics here is n 1 minus 1 S 1 square by sigma 1 square will follow chi-square distribution with n 1 minus 1 degree of freedom. Yes or no? You go for population 2, that variance is sigma 2 square, you have collected n 2 sample, size is basically n 2, then you have calculated variance, sample variance. Can I not say that n 2 minus 1 S 2 square by sigma 2 square, this is chi-square distributed with n 2 minus 1 degrees of freedom? We can say, if we can say this, we also can say that f equal to n 1 minus 1 S 1 square by sigma 1 square divided by n 2 minus 1 S 2 square by sigma 2 square. Okay. We can create like this, but what we said earlier, that if this quantity is divided, what we said earlier for F distribution? F distribution, we say F is the ratio of two chi-square variable, chi-square, suppose nu 1 degrees of freedom divided by nu 1, followed by the denominator case chi-square nu 2 degrees of freedom divided by nu 2. Okay. So, if this is the case, then we will create like this. What is our chi-square variable here? Chi-square, instead of write this, I am writing now chi-square. You please write, see that nu 1 is n 1 minus 1 divided by n 1 minus 1, then chi-square n 2 minus 1 divided by n 2 minus 1. Can you find out what will be this from this? We say this one is chi-square n minus 1. So, this divided by n 1 minus 1 means this is S 1 square by sigma 1 square. Now, but denominator will be S 2 square by sigma 2 square. So, this definitely follow chi-square F distribution, and that is the F. What will be the numerator degrees of freedom? Follow from here, what you have divided here? N 1 minus 1. So, n 1 minus 1. Now, what is the degree of this one? N 2 minus 1. So, you have to tell like this, that n 2 minus 1. So, this is the distribution. Getting me? So, you know the distribution. You very well know S 1 square by sigma 1 square divided by S 2 square by sigma 2 square follow F distribution with n 1 minus 1 and n 2 minus 1 that numerator and denominator degrees of freedom. Can you now develop? You cannot develop. You know that. So, what is our statistic? Your statistics is S1 square by sigma 1 square, S2 square by sigma 2 square, that is the divided by this. This follows F distribution. So, your F distribution is like this. F, you are saying that this one follows F distribution. What we want to create? We want to create the interval. You create like this. Earlier also you have seen this. This is my U and let this is my L. Okay. So, this one is, if I consider alpha, then this side probability this will be alpha by 2, this side probability will be alpha by 2, but the right hand side probability, if I consider the entirety here, this total probability here, this is 1 minus alpha by 2. So, 1 minus alpha by 2 will be this probability. Then corresponding F values you will be getting. What will be the F value here? F is our N1 minus 1, N2 minus 1, that is the degrees of freedom, numerator and denominator degrees of freedom, but this is corresponding 1 minus alpha, that probability value. That probability value, for that probability value, what is the value of F? Then that means L equal to this. What is your U? F N1 minus 1, N2 minus 1, this is alpha by 2. Now, again you know that F equal to S1 square by sigma 1 square, S2 square by sigma 2 square, and also we say that probability that this quantity less than equal to F less than equal to this equal to 1 minus alpha. It's okay. Now, instead of S, what you require to put, you write down this one, S1 square by sigma 1 square divided by whole divided by S2 square by sigma 2 square. So, I want, what you want ultimately from here? You want a expression where in the middle portion there will be sigma 1 square by sigma 2 square, then set the left and right hand side. Can you derive now? You take 2 minutes, take 2 minutes and derive. Essentially, why I am putting so much of effort here, because you see that all the cases procedure remains same. You have to know the statistic, appropriate distribution, lower bound and upper bound, that based on alpha value and probability of this will be this, then your interval is. Now, not necessarily that these quantities, suppose some other quantity you are deriving and you are able to find out the appropriate statistics as well as its distribution, you can create the interval. Getting me? It is very simple. So, so what we have done then? We found out that F N1 minus 1, N2 minus 1, 1 minus alpha by 2 less than equal to S1 square by sigma 1 square, S2 square by sigma 2 square less than equal to F N1 minus 1, N2 minus 1 alpha by 2. You want sigma 1 by sigma 2 that whole square. So, you have to, what you require to do now? You require first take the inverse, in the sense ratio that is reciprocal. If you do the reciprocal part, what will happen, that this will be greater than. So, if I write like this, ultimately what will happen, the resultant part, if you write like this, can you not write like this? Then I am writing, it is going up, sigma 1 square by sigma 2 square into what is remaining here, that is S 1 square by S 2 square. It is basically this one. I want to give a inverse sign. So, that is a, so S 2 square is there, it will go up, S 1 square will come down. Here sigma 1 square was in the denominator, it goes up, sigma 2 square come down. Then this is 1 by f n 1 minus 1 n 2 minus 1 alpha by 2. Now, I am writing just in other way. So, what we are doing, we are again going to the standard format, the way we write sigma 1 square by sigma 2 square. I am writing like this. So, what will happen, this side portion will come here, and S 1 square, if I take out of this to this side as well as this side, then what will happen here, S 1 square by S 2 square divided by f n 1 minus 1 n 2 minus 1 1 minus alpha by 2, and this side will be S 1 square by S 2 square by f n 1 minus 1 n 2 minus 1 alpha by 2. That is what is. Now, see, if sigma 1 and sigma 2, which one is greater. So, there are again the change, combination changes are there. I mean, if you go to statistical, any basic statistics book, you may find out some other type of derivation, representation, not derivation, same way you derive. So, depending on that possibility is there, because we will not go into that depth, because it is not required for all of us. We have to proceed to, these are all prerequisites for multivariate statistical modeling. So, we have to finish as early as possible. I am planning to finish by another lecture the prerequisite, so that we will straight away go to the start the multivariate one, that what is the ultimate aim when you are looking for. Okay. If this is the case, so can you not find out some, suppose this is the one of the example, so two medicine, that is treatment of asthma. There are two different type medicine, maybe you are taking some medicine or you are using inhaler, okay. Or let it be the two different type of medicine also only you are consuming. Now, there are the manufacturer is claiming that maybe medicine, both medicine is working as usual or not. I mean, they are saying that they are comparative in the sense. Then when we talk about comparative, then one of the issue is mean value. You have to find out a response variable. We are saying that response variable is that once I take the medicine, how long it will take me to get relief from the asthmatic problem. That is, we are saying that average relief time. So, if I take medicine A, and these are all emergency medicine, in the sense that when the asthma problem will occur, that time you are taking for relief purpose, let it be like this. Then if you take medicine A, then what we have found out that average relief time is 2 hours. If I take medicine B, average relief time is 3 hours. And you have checked with 20 patient for medicine A and your 25% using medicine B. You got this average time and also you got the sample standard deviation, both are 2 and 2, okay, from the 20%, from the 25% for medicine A and medicine B. Now, you may be interested to see that using this information you may be interested to see the confidence interval for the variability part. Okay. It may so happen, why variability is important, it may so happen that the same medicine, for the same medicine one patient, but let Mr. X is getting cure relieved by 1 hour, for Mr. Y it may be 3-4 hours. So, that variability, because as we have already discussed, variability is a very important issue. So, we want to, using this you want to test that okay, what is the that interval, it will vary. So, you can very easily calculate, then you not calculate, definitely you will be able to calculate, because S1 square and S2 squares are, what are those things, S1 in this example what is our S1 square, 4, that is S1 and